The first thing we need to do is set up our project in Metashape Pro so we can start processing all the imagery. So we had two flights here, a north flight and a south flight. Those need to be brought into Metashape Pro and then converted to the projection. In this case, our projection is Arizona Central, and that will be on international feet. There's no setting in here for international feet. It's just using the coordinate values at this stage. So the coordinate values and the GCPs that we'll later constrain to are going to control the location in space. So when we bring the imagery in, as you can see here, the next step is to align the photos after we've got our projection set. Okay, so I have aligned these images. It's 363 images and they've been aligned. So that will take and relate each image to the adjacent image. Once we align them, then we select all of them, and then we'll uncheck them here. What that does is it allows the images to be adjusted to our GCPs when we get those tagged. If we left them checked, then they're going to hold these positions, and constraining them to the GCPs will have no effect. Now we can also look at the accuracy here from the RTK values, uh, easting, northing, and elevation. So that's the relationship with each image to each other is in that accuracy range, which we could process the site with just that data, keep these images checked. We could go through the full process and it will hold these values, which I have tested and it's pretty accurate. But what we have to do after the fact, because these are all going to be in grid values, uh, approximate grid values, because we're using an autonomous position for our RTK based setup. It was not set over unknown point. So the resulting ortho and DSM that we'll later extract from here would then need to be scaled to ground and adjusted horizontally and vertically to some known point. With ground control points that we have here, we can bring those in, uncheck all the imagery, bring the ground control points in. As you can see right here, these are the ground control points. Then we can now take and walk through each image that corresponds to each of these ground control points to tag them. So I'm going to switch over here to the model space. Let's go ahead and turn this on, because when you align it, it's going to have a rough point cloud just to kind of based upon the automated tie points that it finds when we align the imagery. So now we can come over here, we can filter by markers. And since we've already got them tagged, they're going to be on the point. Initially, these are not lined up with the targets. You have to go through and select 3 different targets. And what I did initially is I selected that one. I selected this one up here, 40,009 and 40,006. So you got to have three of them tagged with at least two images at each one of those points. Then you come over here and run the initial optimization, and that will adjust all of the control points to, or not correction, it will adjust all the imagery to fit the control points to those values. Then you go back through each of the control points, and then you start tagging them. So you have to walk through every one of these, tag the center of the target with that control point, which gives you the little green flag. So you'd walk through all of these. It's a little time consuming. This is a little larger site. We've got quite a few ground control points. So you'd need to go through every one of these images and tag them and have the little green flag on the center of the target. What that will do then, will start adjusting the imagery to fit the target. Once you get them all tagged and you walk all the way through and do every one, then you run the final optimization. And I go with the default here. I don't mess with changing any of those settings. I just go with the default, we click OK, and then it will take and align the imagery, and then we'll check, at that point in time, you check the residuals. What this does is it's going through least squares adjustment through all of the images that we've tagged, and it will run through the least squares adjustments to see how they fit ground control points. This is fairly typical for large sites like this. It starts, when this starts, the horizontal values always kind of fall in this range, sometimes the lower. The This has to do with the flying height and the ground sample distance resolution. This here on the vertical also has to do with the number of GCPs, and the layout of the GCP. So these are pretty balanced, which gives us a good strong aerial triangulation. If they were not balanced, then these would start fluctuating some. Okay, so you can go through here and tag and untag by checking the box and seeing how much floating would be going on if I didn't hold that 40,002. If I uncheck that, you can see that there's a little bit of floating on the vertical. So that GCP is absolutely needed for this large site in order to tighten up that vertical. So you can actually go through and uncheck and check these and see what kind of floating is going on. So we got some floating going on this side, but that's also typical. It's never going to be exactly zero. We could add more GCPs in here and tighten that up some, but this is well within tolerance to meet ASPRS standards and our 1-foot contours that we're going after. So this is a good result. So once we've taken and ran our final optimization and we've reviewed the residuals, the next step is to build the dense point cloud, and that will take some time to build. So I've already built it here. And you can see here that the processing time, the initial was 3 hours, 9 minutes, and the final was another hour. So that was roughly 4.5 hours of processing that site for 963 images. We get the dense point cloud, then the next step is to build the DEM, which is also the DSM. So let's go here, let's turn that on. Go ahead and turn these guys off. So now we've got the DSM built. And now we have, if you look down here, so wherever you move it, you're going to have elevations. Now that's going to be the digital surface model or digital elevation model. Either one, they're both the same. And that, excuse me, that will be uh, that we're going to export here in a bit. Once we build the DEM model, then we can build the ortho. That's going to stitch all the images together. We can take and look at the seam lines here. It's updating, there we go. So the seam lines is, you can see here, I'll go ahead and zoom in. That's taking each of the images and it's finding that neat area for that image and the next adjacent image, and it's stitching them all together. So that neat area that you're seeing here is the minimal distortion of the overall image. I go into detail in my books on the image neat area and how to calculate it. So once we get, let's go ahead and turn those off. Once we get the ortho and DSM built, then we can take and export. We create our, this one here is our mapping limit. So that one we would export the ortho. And then we want to export a slightly larger site for the DSM, which both of those will be used in Global Mapper to extract the breaklines. So we've gone through the process here of, not in detail, but we went through the steps to build the ortho and DSM because that's what we're trying to get out of this flight. We'll move on to the next step, and that's creating the break lines in Global Mapper. Now that we've got the ortho and DSM created from Metashape Pro, we can move into Global Mapper. So we'll bring in the DSM, and then we'll bring in both the orthos. In this case, the site's big enough that we had to split the ortho into 2 JPEGs in order to be able to export them. First thing we do is when we're in here, we need to go ahead and create a limit line around the shape of both the orthos. So we'll create a layer, call it limit, and as you can see here, it's drawn around the boundary of the ortho. Now the next thing we'll do is there are a couple of features on here that we want to hide. So we'll create a hide limit as well. Let's see, what do we got here? So we've got some kind of concrete structure. So the hide limit is where we're going to hide the contour lines in Civil 3D. And we got a couple areas up here where there's some holes in the ground that the construction crew is working on. Okay. So we're going to turn. Now we'll go. So the next two layers are going to be a BL1 layer, break line 1, which is for man-made features, and break line 2, which is for natural or dirt features. So let's turn on BL1, and then for this site, there's very little uh, man-made features, which in this case happens to be this road. So there's 1, 2, 3, 4, so there's 5 break lines that are drawn along the edge of pavement, center road, um, over here on the edge. So those are set roughly, the vertexes on those are, in this case, because it's flat, between 10 and 20 feet apart. Doesn't have to be exact, it just needs to be able to capture any vertical changes along that road. And like I said, in this case it's flat across there. There's a little bit of crown, that's why we have the center one in here. And that will give us the vertex points that we need and break lines to control the tin model once we build that here in a second. Now we're going to build it in Global Mapper to check it, but then we're going to rebuild it in Civil 3D using the tools in Civil 3D. So let's turn off the ortho now. Turn on the DSM. Now we need to add the BL2 layer, which is for natural features. So here we need to, kind of the separation between each of the break lines here is going to be about 10 feet. That gives us pretty smooth contours. Let's just start. Let's just look right here. And as we're going through here and setting each one of these where these vertexes are, you want to make sure that you're clicking on the ground and not on top of bushes, trees, anything that's above the ground. So as you're drawing these lines, you want to draw them, you want to draw them along. I start with grade breaks first, which is kind of like toe wash and top of wash. I do those first, all the major um, break lines. And that kind of gives me an outline of how the flow is going. It is a little bit of what time consuming to do this, but it helps with building the surface in Civil 3D and controlling how the break lines or how the tin model is constructed. So this particular site here is fairly large, and it It took a couple of days, I think almost 3 days to draw all these break lines. So now you can, the break lines start outside the mapping area. Because the mapping area where this limit line is, that's where we're going to trim it in Civil 3D. So the break lines need to start out beyond or outside. That's why the DSM, when we created Matrice Pro, is larger than the ortho itself. So as you can see here, as I scroll around, you can see how I've laid out the break lines. I do cover this in detail in my break line books, which I will make a note of at the end of this video. And it shows you how to go through and set all this up. Now once we draw the break lines here in Global Mapper, then they need to be draped to this DSM surface. If we have LiDAR data, which we don't on this particular project, but if we have LiDAR, then the BL2 layer would be draped to the LiDAR surface. The BL1 would be draped to the DSM surface. DSM is a little bit tighter than LiDAR, a little bit. So that's why these hard surfaces, man-made surfaces, it's the BL1 layer is draped to that surface. So once we get the break lines in here drawn and we get them draped, there's a process to go through to drape them. Then we can take and let's turn this off. Let's You can go through and generate the tin surface from the break lines. And you can see here's all the triangles, the tin model. So this is going to generate a lot smoother contours, which I'll show you here in a second. You can go through and review it, see, just make sure it looks right. Right there we got a bumpy. I call them bumpies. So that's probably, my guess is that's probably a dirt mound. But we're going to go confirm it here. We'll take and turn on the ortho, turn that off for a minute. Yes, it is. See, it's a dirt pile. It's not a top of bush. If it's top of bush, then we'd have to delete that vertex we put in there. We have to clean up the break lines a little bit when we do have some anomalies on anomaly. I can't even say the word. When we have those on top of bushes and stuff where they don't need to be. Okay, so once we got the surface, then we can go ahead and generate a contour map just so we can kind of look at it and see if it's making sense. Let me turn that off. Turn that off. So now you can kind of go through and look at the contours. This is how they're going to come out. There's that dirt pile. This is how they're going to come out in Civil 3D. We will trim it along that limit line so these edges will get cleaned up really nice. Okay, at this point, now that we've got it created, we will go through, turn that off, I'll turn these on. These will now be exported out and they will be exported as a DWG file, separate DWG file that we will then utilize in Civil 3D. So that takes care of the global mapper. Okay, let's move into the final stretch here. We've built the ortho, we've built the DSM, we've gone through global mapper, we've created the break lines, the limit line, the hide line, and we've exported those out. Now we're into Civil 3D. So we create the surface, and that's from a template. So standard template that we have set up. And the next step is to bring in limit line, the hide line, break line 1, break line 2. So this is the line work that was created in Global Mapper. So then we turn off. Now I add the -1 here on the layer name so that it sorts it to the top, makes it easier to turn them on and off or freeze them, whatever term you want to use. So now we have all the break lines. So the surface is, I've already created it, but that's where we'll add all those break lines that you're seeing right there. So let me go turn this on. Once we add the break lines, then the surface is created based upon our template settings. And then we add a border. So we've got a border for the outer, so that trims it. And that was the one that we drew in Global Mapper. And then our hide layer, we add that. And that, what that does is just hides the contour lines in those areas. Pretty clean. We take a look at the break lines here. They should look identical to what was in Global Mapper. No anomalies. Okay, so let's turn those off. And then we add the control points for GCPs. And then those we add down here as part of the surface. And we'll take and just look at them real quick just to make sure that there's no weirdness going on with them. And that takes us to our surface. So from here we can save that. It is set up for 1 foot contour. That's our default. Really not much else going on there. And our final deliverables for this job. Now on this particular job, we did not have planimetrics. Clients doing that themselves. You can attach the image file to this. If you want to look at it there, I just look at it in Global Mapper. I'll look at it here and check the contours to see how, make sure they look okay. This one's jumping out at me. They look pretty good, really. Okay, back to here. All right, so the deliverables. Let's see here. Takes a little bit of work to keep track of all this stuff after you've done thousands of these jobs. Alright, so deliverables. Alright, I did not put them in here. I have them. Where do I have them? So here's our deliverables for this particular client. The ortho, the DSM, we've got the surface file here, then we have contour only. I do export that out. I will export that out as a 2010 format. And it's just contour only. In case they don't have Civil 3D, then they can still open this up and use that in whatever application the client uses. And that's kind of winds things up. So just a quick rehash. This is part 4, going through the deliverables is part 4 of the overall process that I use with the Matrice 4 Enterprise. So I hope this is information is good for you, and we'll catch you on the next one.